Welcome to the full solution to the practice questions from lesson 21, which focuses on the intersection of a line and a plane. The first question here is asking us to determine the relationship between this line and this plane. First thing we want to do is, well, we don't have to actually do this, especially if we're more comfortable, but I like to change things into parametric equation. X here is going to equal to -2 plus 3 times t. Y is going to equal to 6 plus t times 2. And z is going to equal to 5 plus t times 1, which is just t. Once we have this, we are going to use the x, plug it into here, y, plug it into the y value of our plane, and z, plug it into our z value of the plane, and solve for the t value. In this case, we are going to have 2 times x, which is -2 plus 3t, plus minus 4 times y, which is 6 plus 2t, plus z, which is 5 plus t, plus 25 is equal to 0. I'm going to expand here. 2 times -2 is -4. 2 times 3t is 6t. -4 times 6 is -24. -4 times 2 is -8t, plus 5 plus t is equal, or plus 25 is equal to 0. I'm going to collect my like terms here. I'm going to have all the constants and all the ones that have our variables in. As for the pink here, I have -4, -24. That makes -28. We got 5 and 25 will make 30, and 30 minus 28 is +2. And as for the purple, I have 6 minus 8, which is -2, plus 1, which is -1. So that's -t is equal to 0, and therefore if I rearrange this, I get t is equal to 2. So this means that at t is equal to 2, the x, y, and z will be the same for our line as they will be for our plane. So we can figure out the point of intersection by going back and plugging in the equations or the t value of 2 into these equations. So x is going to equal to -2 plus 3 times t, which is 2. That's going to equal to -2 plus 6, which is 4. For y, we are going to have 6 plus 2 times 2, which is 6 plus 4, which is 10. And for z, we are going to have 5 plus t, which is 2, which is going to equal to 7. So therefore, they will intersect at points which will have coordinates of 4, 10, and 7. For the second question, we're asked to determine the parametric equation of the line which goes through points A and B, and then determine its point of intersection with this plane. So to find the parametric equation, we have to find the vector first. And we are going to use vector AB. You can use BA, it doesn't really make a difference. I'm going to take the coordinates of point B and subtract them by coordinates of point A. And I will end up getting 2 minus 1 is 1, -1 minus 2 is -3, and 3 minus 0 is 3 as well. Once I have this, my equation is going to involve one of my points, either A or B. It doesn't make a difference. I'll use A. The numbers are closer to 0. And that equation is going to, its x coordinate is going to equal to 1. I'll do all the points first. So 1, 2, 0. I'm getting all those points from here. And I'm going to use the direction vector 1, negative 3, 3. So it'll be 1 times t, negative 3 times t, and 3t. So I'll rewrite this in simplified form, 1 plus t, 2 minus 3t, and 3t here. Now to figure out the point of intersection, I will plug in the x value here, the y value into the y of my plane equation, and the z value into the z. So I will have x, I'll just rewrite this, x plus 2y minus z is equal to 5. So my x is 1 plus t plus 2 times my y is 2 minus 3t, and my z is 3t, and that's going to equal to 5. I will then expand, plus 2 times 2 is 4, 2 times negative 3t is negative 6t, minus 3t is equal to 5, and I will collect my like terms. I will have 1 and 4 that make up 5, so that's 5 plus t minus 6t minus 3t. So that's negative 9, negative 8. So I'll rewrite this as negative 8t is equal to 5. Subtract 5 from both sides. I will get negative 8t is equal to 0, and therefore t is equal to 0. So that means the point of intersection happens when t is equal to 0. I will use these set of equations to figure out my final points of intersection. So x is going to equal to 1 plus t, which is 0. So that's 1 plus 0 is 1. Y is 2 minus 3 times 0, which is 2. And z is going to equal to 0. Therefore, they will intersect at point 1, 2, 0. Okay, for our last question, for the first part, we are given a plane and we are asked to determine the point of intersection with the z-axis. Well, the first thing we want to do is write this equation in its scalar form. So we have the two vectors, the two direction vectors, and we need to change those. We need to get the normal of the vector by getting the cross product of those two. So I'm going to call this vector b and this vector c. So b and c, their cross product will give me the normal. And let's do that here. For my first vector, my components are negative 2, 4, and 7. And for the next one, they're negative 7, 6, and 3. So I'm going to have 4 times 3, which is 12, minus 6 times 7, which is 42. And then my y component, or negative y component, is going to be negative 2 times 3, which is negative 6 minus 7 times negative 7, which is negative 49. So this is going to be plus 49. And finally, for the z component, I'm going to have a negative 2 times 6, which is negative 12, minus negative 7 times 4, which is negative 28. So that's positive 28. Once I put all these together, for the x component, I will get negative 30. For the y component, I will get positive 43, or negative 43, sorry. And for the z component, I will get 16. Now, to find the equation of the plane, I know that this is my a value, this is my b value, and this is my c value. I cannot simplify them, so I'm going to write ax plus by plus cz plus d is equal to 0, and my a value is negative 30 plus b, which is negative 43 plus 16z plus d is equal to 0. I'm going to use this point over here to figure out what my d value is. So that's negative 30 times 6 minus 43 times y, which is negative 4, plus 16 times z, which is 3, plus d is equal to 0. Now I will get negative 180 plus 172 plus 48 plus d is equal to 0. That is 40 plus d is equal to 0. That means d is equal to negative 40. And that means the Cartesian form of my equation is going to equal to negative 30x minus 43y plus 16z minus 40 is equal to 0. And you can also just multiply everything out by negative to get rid of the negative here if you want. So let's do that actually. We will get 30x plus 43y minus 16z plus 40 is equal to 0. And that's my Cartesian form. Let's box this because we're going to need it for the rest of our answers. The first part of the question is asking us to determine the point of intersection with the z-axis. Well, we need an equation for the z-axis. We need an equation of the line is really what I wanted to say. So this is x, y, and z. And for the z, we have a starting point. We can just use the origin as the starting point. So that's 0, 0, 0. And its direction, well, that's nice because it doesn't move in the z direction. It doesn't move in the x direction. It doesn't move in the y direction, but it does move in the z direction. So therefore its equation in vector form is just 0, 0, 0 plus t times 0, 0, 1. And if we want that in a Cartesian form, x, I'll write it out here, x is equal to 0 plus t times 0, which is 0. Y is equal to 0 plus t times 0, which is 0. And z is going to equal to 0 plus 1 times t, which is t. So now I will come back and use this equation in my Cartesian form. So x is equal to 0, y is equal to 0, and z is equal to t. And let's solve for t in this case. So I will have 30 times 0 plus 43 times 0 minus 16 times t plus 40 is equal to 0. So that means I'm going to rearrange and get 16t is equal to 40, and t is equal to, I'm going to divide everything by 4. I will have 4t is equal to 10. T is equal to 10 over 4 or 5 over 2 simplified. That means my point of intersection, going back to my points here and plugging them in, my x value is 0, my y value is 0, and my z value is t, or 5 over 2. Therefore, point of intersection here will have an x value of 0, y value of 0, and z value of 5 over 2. And that is my point of intersection with the z-axis. And it makes sense also because, these two values make sense because if there's an intersection with the z-axis, there should be no x or y value. They should be 0, and it is in our case here. For the second part of the question, we're asked to determine in which line the plane intersects with the XZ plane. So let me move everything up a little bit so we can see the equations that we have derived, and we want to see the line for XZ plane here. So if we were to draw the coordinates y, x, and z, the xz plane would be well, it's very difficult to imagine this because I'm just drawing it in 2 dimensions, but what we're trying to figure out is we got this plane over here, and when it intersects with this other plane, it's gonna intersect at a line, and we're trying to find that line there. Well, in this case, the plane over here basically has a y value of 0 everywhere. It will have different x values, it will have different z values, but the y value is consistently is equal to 0. So in this case, y is going to equal to 0, and that is the plane where the line, where the two planes actually meet. This is one of the planes. So if I were to plug that back into our original equation, 43 times 0 minus 16 times z plus 40 is equal to 0, then I would get 30x minus 16z plus 40 is equal to 0. Well, in the next, not in the next video, but in the video after, when we start talking about intersection of two planes, this will become a little bit easier to understand. But for now, what we can do, we know that equation of a line will require a parameter. And the parameter that we usually use is t. We can give that parameter to either z or x. It doesn't actually matter in this case, but I am going to let z equal to my parameter t, and I will use that, and I will write 30x minus 16. Instead of z, I'm going to use t, plus 40 is equal to 0, and I'm going to solve for x in terms of t. So I will have 30x is equal to, I'm going to subtract both sides by 40, I'm going to subtract both sides by negative 16t, or add 16t to both sides, and I will get this. And finally, I will divide both sides by 30, and I will get x is equal to negative 40 plus 16t over 30. This will become the parametric equation of my line, and in this case, we know that y is equal to 0 is my other one. So the line at which they will meet will have x value of 16t minus 40 over 30. It will have y value of 0, and it will have z value of t. And that will be the line at which the two planes will meet. And again, if you're having difficulty with this one, don't worry yet, because soon we will be covering the intersection of two planes, and this will start to make a lot more sense afterwards. I hope that this video gave you some practice with the intersection of a line and a plane. And again, practice, practice, practice. If you were a little bit stuck with the last question, please do not worry, because we will be covering that one in more depth. And thank you for watching the video.